All right, so in this discussion, I'm going to go over Climate Change 101. So this is another one of those really big topics. We're only scratching the surface, but hopefully I can give you some insight into sort of our climate goals that need to happen, how climate change happens, and how it relates to the greenhouse effect. What is the greenhouse effect? What roles do fossil fuels play in this whole process? And then we'll go over some basics of greenhouse gases and why carbon dioxide is such an important consideration. So you need to write this down. It's really important. It's very fundamental to this whole issue. There is very wide agreement that the world must be carbon neutral by approximately 2050 to avoid the worst impacts of climate change. Okay, that is widely agreed upon. That's where we need to head. So carbon neutrality, which we've discussed before, means either we're not emitting any CO2 or any CO2 that we're emitting is absorbed by either things that we're doing or natural processes. Where are these emissions coming from? Pretty clear. The big red part of the circle here is energy. That's where most of our greenhouse gas emissions are coming from. You got about 20% for land use, and then there's some other minor. You feel free to look at this, and I provide a link down there. But this really, you can break it down into different sectors. But energy use is the big one, and we'll discuss that here in a minute. So who's most responsible? So if you've heard anything about China and their level of responsibility, yes, they emit more greenhouse gases than any other country in the United States. So you can see this is from the little before the Industrial Revolution through today, and this just shows you who is emitting what percent of greenhouse gas or CO2 emissions, excuse me. So China is about 25-30% of total global emissions. The United States is about 15%, give or take. So China is the world leader in total emissions. Okay. However, if you look at the per person or per capita emissions, the United States, of all the major emitting countries, is right near the top, along with Australia. And compared to China, we're actually about 15 tons per year per person. China's about 7.5. So we're about twice the average Chinese person in terms of the emissions we're responsible for. Also very important to remember is that CO2 lasts hundreds, if not 1,000 years in the atmosphere. So if you want to look at who's most responsible, you have to look at who's emitted the most over the last 250 years or so since the beginning of the Industrial Revolution. If you look at the cumulative emissions, this breaks it down by area, or excuse me, it shows it as area, and the biggest area is the biggest emitter. So the U.S. has about 25% of global cumulative emissions. The entire European Union is about 22%. So US 25, EU 22, China is about 13%, India is like 3%, and then all of the continent of Africa, believe it or not, all of the continent of Africa is here. Okay, so that's Africa as a continent. That's USA as a country, right? So that's EU as a continent as well. And this is South America as a continent. So you can see that the United States, if we're looking at who's most responsible, it's really, we are by far the primary one. So that hopefully provides some context in terms of what the goals are. So we have to be carbon neutral by about 2050 in order to avoid the worst impacts of climate change. China is the world leader in emissions. USA is number 2, but per capita emissions were about twice that of China, and that the United States is by far the single biggest emitter over the last couple of hundred years. Okay, so let's go over what the greenhouse effect is and how it works. And I want to just be really clear, there's no controversy here. We know what the greenhouse effect does. We know how it works. We've known it for over 100 years. We also know that without the greenhouse effect, that life on Earth would not be possible. So how does it work? It's all based on greenhouse gases. Okay, so the Earth, and I did post a video about this, the Earth has an atmosphere, as I'm sure you know, and there are greenhouse gases floating around in that atmosphere. So sunlight comes in as shortwave radiation. Okay, so solar radiation is shortwave. We've talked about this before. Comes in as shortwave radiation based on the temperature of the sun. Comes in, and the key here is that these greenhouse gases, the sunlight passes right through them. Okay, so that shortwave radiation flows right through them, And then if it reflects off of something like, say, the top of a cloud or like a light colored surface outside, if it reflects, it's still shortwave, and it'll just bounce back out and pass right through the greenhouse gases. Okay? So if it stays shortwave, it doesn't matter if it's coming down or going out, it's just going to pass through. Now, if it's absorbed by something on or near the surface, you name it, look outside, grass, you walk outside, your skin, your clothes, your hair, whatever, all of that absorbs the sunlight, and we know this, it warms up, right? That's that heat transfer, that radiant heat transfer. And then you warm up, or whatever it hits warms up, and that radiates energy back out. Well, that energy is what's called long wave radiation or infrared radiation. And again, we mentioned this before. So remember, you know that everything around you is radiating all the time. Almost all of that is long wave radiation because the objects around you are not that hot. Not hot like the sun anyway, unless it's like an incandescent lamp or something. Anyway, that long wave radiation goes up, and here's the key. The greenhouse gases are really good, really effective at absorbing that long wave radiation. And so what happens is these greenhouse gases absorb, let me draw a little thing here, these little greenhouse gases are in the atmosphere, right? That long wave comes up, and it's absorbed, and then they emit that radiation in all directions, all around, okay? So it's just like anything else. They absorb it, they get hot, and they radiate. And when that happens, about half of the radiation will go down toward the surface of the Earth. And that's it. And so what it does is actually kind of like a blanket. It's not exactly the same, but you can think of it like a blanket in that it traps heat, right? And so without these greenhouse gases, the Earth would be much, much colder on the order of like, I forget the numbers, like 60 degrees colder. So life on Earth would not be possible without this. This makes life possible. So you think about, if you're familiar with the moon, for example, it doesn't have an atmosphere. So it just gets really, really, really cold at night, and the average temperature is really low. It gets real hot during the day when the sun's hitting it, but at night it drops, just these horribly cold temperatures. And so that's because it doesn't have an atmosphere, right? So the greenhouse, to summarize, the greenhouse effect is based on greenhouse gases which are in the atmosphere, and they do not absorb shortwave radiation. But then if that radiation is absorbed by something around, on or near the surface, that emits long wave radiation, which is then absorbed by the greenhouse gases, and about half of that goes back toward the surface of the Earth. Okay, and that makes life possible on this planet. All right, so the greenhouse effect is a good thing. The problem is that when we emit too many greenhouse gases, then the Earth is warming more than it would otherwise be. I just want to be really clear. There's a difference between the ozone layer and climate change. So the ozone layer is in the stratosphere, and that actually is ozone molecules that prevent ultraviolet radiation. Okay, so this is really important, but it's not the same as the climate change. So to be really clear. Okay, so what are these greenhouse gases? There's actually a whole bunch of them. I'm not going to go over all of them in a bunch of detail, but the two main ones that we're worried about are CO2, or carbon dioxide, and CH4, which is methane. Okay, and so if you look at the concentration of CO2 and methane over the last 2,000 years, which is this chart over here, you can see where there's no year zero, but 2,000 years ago, common era to today, and then here's your concentration in the atmosphere. So it's important to note that concentration. So just because the United States emits more CO2 than most other countries doesn't mean like the climate's changing more in the United States than anywhere else. It just goes out and distributes globally. So this is just a global measure of the concentration in the atmosphere, and it's measured in parts per billion. The CO2 is. So what's going on in this chart? You can see at the 8,500 to 1,000 to 1,500, like it's pretty steady. It goes up and down a little bit, but there's an obvious point at which the concentration goes up significantly right here. So you notice that's around 15, 16, 17, right around the 18, mid to late 1800s. And so what happened there was we started burning a whole bunch of fossil fuels. If you know anything about the Industrial Revolution, coal, and then oil, and then natural gas, okay? So this is really clear that the concentration has gone up, and the only possible explanation for it is all of these extra fossil fuels that we were burning. And if you look at the actual potential for different gases to heat up the atmosphere, there's something called global warming potential. And so global warming potential tells you the impact of 1 ton of a greenhouse gas. So CO2 has a global warming potential of 1. It's the baseline, okay? And then you compare everything else to CO2. I don't want to get bogged down in these numbers, but the key here is that methane which is our other major greenhouse gas, which is natural gas is methane, mostly methane. So methane has about 30 times the impact of CO2. So you emit 1 ton of methane and 1 ton of CO2, the methane is going to have about 30 times the impact on the climate. So why are we most worried about CO2? Well, here's why. So the Earth naturally emits about 770 gigatons of CO2 per year. You don't need to know these numbers or anything. These numbers change depending on whom you ask. But so the Earth emits and absorbs about 770 gigatons of CO2 per year. There's something called the carbon cycle, which involves things like the oceans absorbing CO2 and then releasing CO2. The soil absorbs CO2 and release CO2. Plants absorb CO2 when they grow, release CO2 when they die, right? So it's constantly cycling around the Earth system. And so it's roughly balanced out. Okay. The problem is that humans add about 40 gigatons of CO2 on top of what the Earth already emits. And so the result of this is that the concentration goes up. I mean, that's that simple. And our basic sustainability tenet, one of them is we can't emit waste any faster than they can be reabsorbed, right? So we kind of refer to that in our sustainability lesson. So if we want to balance things, if we want things to stay in balance, and we're emitting waste, we have to reabsorb those wastes at the same rate. Well, you can think of CO2 as this waste that we emit, dump into the atmosphere, and if we're not absorbing as much as we're dumping, then we have the concentration go up over time. So that's a big problem. And this is just a chart that shows we've been measuring CO2 directly since 1958 over Hawaii, and this shows the exact trend over the last 60, 70 years. Okay, so why are we worried about carbon dioxide? So this chart actually shows you from 1990 to about 2019 which gas had the most impact on the atmosphere that humans emitted. Okay, so this is which gas had the most, or what percent of the impact on the atmosphere. So it doesn't take a climate scientist to figure out that CO2 is by far our biggest impact on the climate. So this includes the fact that methane is 30 times more potent, right? So if we looked at the actual emissions of methane, it would be like 30 times skinnier than this, is one way to think about it. But this is our impact on the climate. The point here is that CO2 is far and away the gas that has the biggest impact on the climate that humans emit, okay? So where are all these emissions coming from? Well, these are the emissions by source in the United States, okay? So the most recent data I could find is from the EPA. So where are these emissions coming from? Electricity, okay? It's from burning fossil fuels, burning coal, natural gas, a little bit of oil. Transportation, where's the CO2 coming from? Think about where transportation CO2. It's from burning oil or burning gas, which comes from oil. What about industry, like factories and so forth? Guess what? That's from burning fossil fuels. What about in residential and commercial buildings? Where's the carbon dioxide coming from there? Well, burning fossil fuels, burning natural gas, burning oil, burning propane. So all of these things come from fossil fuels. So there's a little bit, this little non-fossil fuel combustion part, about 6%. The takeaway here is that most of our CO2 emissions in the United States come from burning fossil fuels. We talked about that earlier. We talked about the fact that when you burn fossil fuels, it emits CO2. Okay, and about somewhere between 90 and 95% of our emissions in the United States come from burning fossil fuels. So the best way, the most effective way to reduce emissions is to reduce fossil fuel use. That's why you hear so much about climate change in the context of burning fossil fuels and changing the transportation sector, changing the building sector, and so forth. And I'd also think it's important to point out that not only are we setting records for CO2 concentrations every year in the modern times, but if you look at about the last 400,000 years and even further, if you go back like 800,000 years, the CO2 concentration is higher than it's ever been in close to the last million years. So we're clearly throwing this whole carbon cycle out of whack, and we are seeing we're starting to see some of the impacts of it. I won't get into details of the impacts. That's something you can look up on your own, but hopefully you're aware of some of these things that are going on right now. So just sort of wrap it all up, remember, we have to be carbon neutral by 2050, have to, as a global society. And if you look at who's emitted the most CO2, it's been the United States over the past 200 plus years. Even though China emits more now, the US emits per person now. Remember, greenhouse effect. This actually makes life possible on planet Earth. However, we are overstretching the Earth's ability to reabsorb these gases and therefore causing the climate to change. Remember that the greenhouse effect is based on the ability of these gases to absorb long-wave radiation and to allow short-wave pass-through. Carbon dioxide is by far the gas that's emitted most by humans and is having the biggest impact on the climate. And remember that most of our CO2, almost all of it in the United States, and a lot of it globally, like somewhere 70-80%, comes from burning fossil fuels. Okay, so hopefully you have a decent understanding of what climate change is, the major climate change goal that we need to achieve, and sort of how the greenhouse effect and greenhouse gases tie into all of this, and finally how energy, and particularly fossil fuel use, ties into it.